Okay, 5.5, modeling periodic word problems. So to determine the equation of a real-life situation involving trigonometric functions, read the problem carefully and try to identify each of the following. Okay, so when we're reading word problems, try to identify the maximum and the minimum. With the max and the min values, we're able to calculate equation of axis and amplitude. Okay, we know that the maximum is the equation of axis plus the amplitude. The minimum is the equation of axis minus the amplitude. Okay, we're also trying to determine the period. Oh, I'm going to do this as k. Okay, the period is 360 over k. Okay, how long it takes to do one full cycle of what's going on in the word problem. Okay, then determine each of the following from the above information. So if we have the max, min, and period, we can again determine the amplitude, which is max minus min divided by 2, equation of axis, average, max plus min divided by 2, and then the critical interval, which is our period divided by 4. Okay, first sketch the curve that takes into account the A and we're going to go K values. Okay, we talked about this. The A value, we're basically labeling our y-axis, and our K value allows us to label our x-axis. Okay, we're going to change this to K. Okay, this will take into account all stretches and compressions. Reflections we're going to do by patterning. Then second, we're going to sketch like the phase shifts, the H and the C values. So we're going to change this, so it's consistent. Okay, y equals a sine k x minus h plus k, or plus c. Okay, same thing for cos. So then we're going to just shift our graph. Okay, so we already went over an algorithm, but here's the algorithm for sketching sinusoidal functions in word problems. So we're going to create the scale on the x-axis using critical intervals. Okay, and we're going to create the scale on the y-axis using the max, min, and equation of axis values. Okay, we're going to mark our max, min, and equation of axis on the y-axis. And then what I always do is I make a horizontal dotted line on the graph where the equation of axis is. Your starting point will be one phase shift away from the y-axis. Okay, so we're going to take a look at the phase shift. And then this is all patterning. So what we're going to do is we're going to either start at a max, a min, or on the equation of axis, and then pattern. And we're going to plot all of our critical points. So sine, as a recall, starts on the equation of axis, max, equation of axis, min, equation of axis. That's going to be our patterning for sine. If we have a reflection, what's going to happen is instead of going up to a maximum at first, sine will go down to a minimum, equation of axis, then a maximum, equation of axis. Okay, now cos. When we're plotting cos, we start at a max, equation of axis, min, equation of axis, max. That's normally our cos curve. If we have a reflection, then we start at a min, equation of axis, max, equation of axis, min. So if there's a reflection, all that's changing is the patterning. So here is example 1. The height h in meters above the ground of a rider on the Ferris wheel after t seconds, so t is time in seconds, h is height in meters, can be modeled by the sine function this. Determine each of the following, then graph the function. So we're given an equation, so this is not as difficult of one because we can pick out the max height. Max height is going to be equation of axis plus the amplitude. Okay, equation of axis is here, it's 12. Amplitude is here, it's 10. So our max is 22. Our minimum is equation of axis minus the amplitude. So 12 minus 10, which is 2. Okay, so we have the max and the min. Equation of axis we already identified. It's y equals 12. Okay, it is in the form of an equation. The amplitude is 10. I'm going to come back to the meaning. The period and the meaning, period is 360 over 3, which is 120. Okay, this time this is measured in seconds. And I'm going to come back to the meaning. Critical interval is 120 over 4. So every 30 seconds, oops, not degrees, seconds. Okay, so this is what happens in this question, okay? We have some Ferris wheel. It looks like this, okay? Rider's board at the bottom. Logically, there's a rider, okay? Logically, the bottom's not going to scrape the ground, so it makes sense that the minimum is 2 meters off the ground. Okay, you're going to board it in the air or else you're going to lose your legs. And then this rider is going to go around the Ferris wheel like this, oops, and come back to the start, okay? And that's why it's periodic. And it's going to go at the same speed the entire way around. So when we're talking about the amplitude, we're talking about like this middle point where the actual like axis of the Ferris wheel is, the amplitude would go 10 up and 10 down. So in other words, this is the radius of the Ferris wheel. Okay, radius. Now, when we're talking about a period is how long it takes for the rider to go around the Ferris wheel one time. Okay, time it takes for the rider to travel around the Ferris wheel, FW, one time. Okay, H at 20, this is just a straight substitution. 10 sine 3, 20 minus 30 plus 12. Okay, so this is a straight substitution. So if you were to do 20 minus 30, we get negative 10 times 3, I get negative 30 plus 12. Okay, sine of negative 30 times 10. Negative 5 plus 12, 7. So basically what this is saying is, like the interpretation of this would be, therefore, at 20 seconds, the rider is 7 meters above the ground. So following the algorithm, if we were to graph this, what we want to do is we want to mark off max, min, and equation of axis. So 2, 12, and then 22. So let's go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. Okay, so here is the minimum, the equation of axis, and the maximum. Now we have a sine function, and let's mark the critical intervals on the bottom. Okay, so critical interval is simply 30 seconds. So every 30 seconds, we are going to plot a point. 3, 6, 9, 12, 15, 18, 21, 24. Okay, so 240 seconds. So here's the thing. We're going to start one phase shift away. If you read the algorithm, one phase shift. So when we talk about phase shift, we're going to the right 30, and that's where we're going to start the sine function, okay? So from the y-axis, we're going to the right 30. That's going to be our first point. And we're only plotting points at maximum, minimums, and the equation of axis. So every 30, we're going to pattern. So sine goes up, equation of axis, minimum, equation of axis, maximum, equation of axis, minimum. Okay? So here's our issue. A rider doesn't start 30 seconds into a ride. The rider has to start at 0, so we have to pattern this down, which is convenient. And it's right here. Okay, we can label this time, and we can label this height. So let's just talk about this. The rider boards 2 meters above the ground because he doesn't want to lose his legs, and he travels to the top of the Ferris wheel within 60 seconds, within a minute, or at a minute, and to the bottom of the Ferris wheel at another minute, which is 120 seconds. So it takes 2 full minutes to go around the Ferris wheel. Okay, and the height of the rider is changing the entire time. Okay, example 2, a Ferris wheel has a diameter of 14 meters. Okay, it makes 1 complete revolution every 16 seconds. So that's telling me the period, 1 revolution every 16 seconds. The bottom of the wheel is 2 meters above the ground. Okay, so that's convenient. So here's our Ferris wheel. This is 2. If the diameter is 14, I'm going to draw the maximum at 16. Okay. Assume each rider boards the wheel at the bottom. So of course the rider is going to get in here. Okay. Draw a graph to show how a person's height above the ground varies with time. So this is going to be time. This is going to be height. And then we're going to model this using a cosine function. So max is 16, min is 2. Okay. If we're talking about the equation of axis, we're talking about halfway between 16 and 2. So that's the average. 16 plus 2 over 2. I get 9. Okay, 9. This little diagram transfers right onto your paper here. 2, 4, 6, 8, 10, 12. Okay, I'm going to go 3s. 3, 6, 9, 12, 15, 18. Let's go like that. Okay, 2 is going to be here. Okay, so this is, oh, we don't have to label 2. 9 is going to be here, so that's our equation of axis. And then 16 is going to be just right here. So that's where all of our points are going to go. Okay, amplitude, the amplitude is the radius, right? We kind of talked about that. So diameter is 14, amplitude is going to be 7, which makes sense because going from 9 to 16 will give us 7, and going from 3 to 9 will also give us 7. Or sorry, 2. Right, that's 2. 2 to 9 will also give us 7. Okay. What is our K value? Okay, so we know that the period is 16 seconds. So our K value, which is directly exactly what we see in the equation, is going to be 360 over 16. So what we put in the equation is going to be 2.5. Okay, if our period is 16, then every 4 seconds, we're going to plot a point. Okay, and this can translate right to our graph. 4, 8, 12, 16, 20, 24, 28, 32. Okay, so let's plot this by patterning. So it says that the rider is bored at the bottom. So I'm going to let the rider board here. So minimum, equation of axis, maximum, equation of axis, minimum. And it can keep going because the more times you go around the Ferris wheel, it's just going to make another full revolution, a full cycle in our graph. So this graph represents that we went around the Ferris wheel once and then twice. And that brings us up to 32 seconds. Now the graph asks us to represent this as a cosine function. So we know that it's going to be y equals the amplitude, which is 7. We're using a cosine function. A cosine function starts at a maximum. So we're going to go from the y-axis to 8 seconds. So our cosine function, we sub in the k value, which is 22.5, and we're going to go x minus 8, because it's 8 seconds to the right, and then plus the equation of axis, which is 9. This is EOA, amplitude, and this is shift. Example 3, the motion of tides can be modeled using trigonometric functions. The h-axis represents the height in meters of the tide above or below sea level. Okay, so when we talk about height, we talk about something called sea level, and this is in real life, and this is referenced as the height equals 0. Okay, so when they measure mountains or canyons, they're going to measure it in regards to something called sea level. The t-axis represents the time in hours, okay, of a day. The motion of a certain tide is described by this equation. So this is the easiest type of question because it already gives us the equation. So we're going to go ahead and graph a function by filling in these boxes here. So we need a max, a min, an equation of axis, amplitude, period, critical interval. Okay, so looking at h of t equals 5 is the amplitude, so we can fill that in. The period we can solve using the k value. So the period is going to be 360 over k, which is 12. Okay, this is 12 hours. The critical interval is going to be the 12 hours divided by 4. So every 3 hours, there's going to be a point plotted on our graph. The equation of axis is at the end, so it's like plus 0, which makes sense. So we can go h equals 0, which makes sense because sea level is like our reference point. So max and min. Max is the equation of axis plus the amplitude. Oops. So 0 plus 5, and then the min is the equation of axis minus the amplitude, so 0 minus 5. Okay, so how we do this just by patterning is we're going to go down to our graph and we're going to mark off the maximum, 1, 2, 3, 4, 5. That's the only point that I need. The equation of axis, which we already dotted, we'll dot the maximum, and the minimum, 1, 2, 3, 4, negative 5 here. Okay, so I'm going to dot the minimum. Okay, our critical interval is 3 hours. So we're going to go 3, 6, 9, 12, 15, 18, 21, 24. 24 hours, that's one full day. Okay, so let's graph this. Is there a phase shift? Yeah, so the phase shift, and remember in the algorithm, the phase shift is, this is actually left 3. Okay, so our sine curve is going to start to the left 3. So let's just mark off a couple more here. Negative 3, negative 9, negative 12, negative 15. So this is just yesterday, which makes sense. Okay, so we're going to go to left 3 and we're going to start on the equation of axis since we're plotting a sine curve. So left 3, that's our start. Now, sine curves go maximum, equation of axis, minimum, equation of axis, max, min, and max. Okay, that's how that's going to look. We can also cycle it back. Usually in word problems, if we have like time, we can't go back in time. However, tides follow the exact same pattern. Okay, so that's our graph. And we can label that if we'd like. H of t equals 5 sine 30 t plus 3. Okay, and then it's plus 0, so you don't have to include that. Okay, now let's use our graph to determine each of the following. So what is the time of the first high tide? So we're going to say the first one is going to occur after 0. Okay, so we're going to be at high tide right at, I would say, midnight. Or time 0. And then we're going to, another high tide is going to occur at time 12. Next one, next high tide at time equals 12. Okay, what's the time of the first low tide? So low tide is going to be down here. That's t equals 6. Okay, that one's an easy one. The first one, it does occur at midnight and then at time 12. So it depends on how you're reading the question. A little bit of open to interpretation. Okay, what is the amplitude? So the amplitude is 5. Okay, so amplitude is 5, which means it is the height of the tide above and below sea level. If you're working with a word problem, you have to put this into the context of the problem. You can't just say, have the height between the max and the min. Okay, you have to say like, okay, well, what are we talking about? We're talking about the tide. We're talking about sea level. You have to put it into context. Okay, and looking at this, the period, we said was 12 hours. Okay, so the period is 12 hours, which means the length of time to cycle through from, for example, high tide to low tide and back to high tide. So just to expand on the time of the first low tide, if we're referencing t equals 6, we're kind of talking about hours after midnight, right? So like time equals 0 would usually start at midnight if we're talking about like the daytime. So this would be like 6 a.m. Okay, 12 would be 12 noon. And I think made a mistake on those numbers. Example 4. Milton is floating in an inner tube in a wave pool. He's 1.5 meters from the bottom of the pool when he's at a trough of a wave. Okay, so what that means in regards to our x and y axis is it's kind of referencing the bottom of the pool. So I'm going to assume that this 0 mark, so the height equals 0, is going to be the bottom of the pool. Okay, and then he's at the trough of a wave 1.5, so that's going to be our minimum. okay? And it makes sense because if you're in a wave pool and you go to the minimum of 0, then what's going to happen is you're going to take off your feet and really hurt your feet on like the bottom of the pool, and then maybe your inner tube is not going to slide anywhere, it might pop, okay? So a stopwatch starts timing at this point. So when he's at the trough of a wave, the stopwatch starts timing. So we're going to say that this is going to be a minimum here. So it's going to look like this, okay? Minimum here. In 1.25 seconds, he's at the crest of the wave. So this is going to be the maximum. Okay, so this here is time equals 0, time equals 1.25, and then over here, because we know that 1.25 is half of our period, then we have to just add another 1.25 or times it by 2, and we get 2.5. Okay? So in 1.25 seconds, he's at the crest of a wave, 2.5 meters from the bottom of the pool. So again, we're referencing the 0, and now we have 2.5. So if we take a look at this, it's the difference of 1, which is going to come into play. So determine the equation of the cosine function that expresses Milton's distance from the bottom of the pool in terms of time. So let's fill in these boxes first. The maximum is 2.5, the minimum is 1.5. The amplitude is going to be max minus min divided by 2. Okay, so I get 1/2. And the equation of axis is going to be max plus min divided by 2, which is going to be 2. So the equation of axis is going to occur at 2. And then from 2 up, it's 1/2, and 2 down is 1/2. Okay, our period, it's straightforward. So our period goes from 0 seconds to 2.5 seconds, which means our K value, we divide 360 by 2.5, and we get 144. Okay, if we're using a cosine function, I'm actually going to go no phase shift. And what I'm going to do is I'm going to use the reflection. You can choose to do the phase shift of 1.25 to the right, but I'm going to just start it at a minimum and act as though the cosine function is reflected. Okay, so what is the equation? The height at time t is going to be the amplitude times cos, but it's the reflected amplitude. Okay, the K value, which is 144x, we're not putting a phase shift because we're using the reflected one, and then plus the equation of axis. Okay, I'm going to comment on B here. What is the amplitude of the function, which is up here, and the meaning? Okay, so in regards to the meaning, this is half the distance from, and continue here, the bottom wave to the top wave. Okay, the other way you can think of it is the distance above, and I'm going to put in like brackets like sea level, or let's go water level. Okay, so the water level, distance above and below water level that the inner tube reaches. Okay, so what happens here is we have the equation of axis, and the inner tube goes 1.5 up and then 1.5 down. Okay, H at 4. So C asks us how far above the bottom of the pool is Milton at h equals 4 seconds. So all we're going to do is sub in 4 to where the t is. I get negative 1/2 cos 144, and then I'm going to sub in 4 there. Okay, remember 144 times 4. Do that together, and then we're going to cos that number. So I get 2.4. So at 4 seconds, he's 2.4 meters above the bottom of the pool. Okay, water level is obviously the equation of axis. Okay, then D and E. If data are collected for only 40 seconds, how many complete cycles of the cosine function will there be? So if you think about it, in 40 seconds, we would divide 40 seconds by the period, right? And the period is 2.5. So there's going to be a full rotation every 2.5 seconds. So that means in 40 seconds, there's 60 cycles. So that kid is going to go up and down, up and down, up and down. Okay, one up, one down, 16 times. Okay, and if the period of the function changes to 3, what is the equation of the new function? Okay, so we've talked about this. The only part of the equation that the period changes is actually the k value. So if we solve for our new k value, we're going to get 120. Okay, so the entire equation is going to stay the same. Negative 1/2 cos 144x. Oh, sorry. X plus 2. The only thing that's going to change is the k value, which is 120 now.